Our last equilibrium topic is Le Chatelier's principle. And this says if a stress is applied to a system at equilibrium, the system changes to relieve the stress. And a stress just means a change. So, if we change concentration, okay, so for lack of creativity, we'll use this same reaction that we have used several times before. Adding a reactant always pushes a reversible reaction in the direction of products. So if we were to add N2, our equilibrium would shift to the right. If we remove a reactant, so if we removed N2, we would shift left. Removing a product. If we were to remove NH3, we would shift to the right. So we could sum it up. Whenever we add, we shift to the opposite side. Whenever we remove, we shift to the same side. And this is with respect to where that thing we added or removed is in the original reaction. Now, changes in temperature. This is the only time the K value changes. But in order to know which way we're going to shift, reactants going to products, we need to know where heat is. If it's an endothermic reaction, heat is a reactant. Exothermic, heat is a product. So you can think of it the same as concentration. When you add heat, it will shift to the opposite side. But you need to know where heat is. Now, changes in pressure. This only works when we have gases, and a higher pressure is going to favor the side with less moles, because higher pressure means lower volume. So if we look at some examples here, we have this reaction right here. Okay, if we remove CO2, okay, that's being taken out, we're going to shift to the right. If water vapor right here is added, we're adding a reactant, so we're going to shift to the right. If the pressure is increased by adding helium gas, we're going to have no change. If the reaction is endothermic, that means heat is a reactant. So if the temperature is increased, we're putting in more reactant, we're going to shift to the right. If the pressure is increased by decreasing the volume, we're going to have no change because we have equal moles on both sides.